So in the next question, triangle ABC is given. There's a big triangle ABC which is given. AD is perpendicular to BC, BAC. BAC is equal to 90 degree, BC is equal to 16, DC is equal to 4, then find the value of x. So in all these triangles, uh, I always suggest my students that you can clearly separate the two triangles so that you can see the two triangles separately and then mark the equal angles on them so that there is no confusion. I understand that this is MCQ, but I want to spend some time on this question so that you understand how to do similarity questions. So what I'll do is I'll separate these two triangles. So I'll take a triangle ABC. I'll separate these. So I'll separately make ABC and I'll make triangle ADC. I'll make triangle ADC. So basically I have separated the two triangles. Now I'll start marking the equal angles and the corresponding equal sides. So this angle is equal to this angle. Therefore, this side would be proportional to this side, opposite to the equal angle. This angle is equal to this angle. They are the common angles. And side opposite to them are these two, this one and this one. And also another side that would be equal, proportional would be this one and this one. So basically you have to clearly mark the equal angles and the equal sides very clearly. And then of course you can find whatever is required. So for example, in this we have to focus on this side, which is the x. This is what is given. This whole is BC. So 1, 2, 1, 2 here, 1 here, and of course this would be the common side. So basically, we will be focusing on these sides and this side. But I've clearly demarcated the two triangles. So this is a bit small. So if you look at here, then it will make sense. So in this case, I know my AC. I have to find this is x. I have marked this is 4. This is x. I have marked that this side is proportional to this side. I have marked that this side is proportional to opposite to 90 this side. So my sides and angles are clearly marked. And now just I have to take the proportion. So I'll write AC upon DC is equal to BC upon AC. So AC square would be equal to DC multiplied by BC. So AC square is my unknown. So AC square would be my unknown. This is x square is equal to DC. DC is 4 and BC is 16. So therefore x would be equal to 16 for the 64. So x would be equal to 8. I ignore the negative sign, of course. So my answer would be 8. So this is what I want to make it clear. So your angles and corresponding sides should be very clearly marked so that there is absolutely no confusion. And what helps me as well as my students is that I separate the two triangles which I am focusing on. So hope this helped, and let's move to the next question. So triangle ABC PQR, okay, measure of angle C. So let's see. Now let's see. See, I have this angle. Let's see the proportionate sides. Let's try to understand let's try to figure out the proportionate sides first, and then we'll see the angles. So if I look closely, I can see a relation. So this is 6 multiplied by 2 is 12. 3 root 3 multiplied by 2 is 6 root 3, and 3.8 multiplied by 2 is 7.6. So these would be the corresponding sides and the corresponding angles would be equal. What this implies is that 6 and 12 have the ratio, have equal ratio. So, angles opposite to them. What are the angles? This is 80. So these two angles would be equal. Hope this is making sense. This would be 80 degree. Now 3.8 and 7.6, what are the equal angles? Opposite 3.8, this angle is there, and opposite 7.6, this angle is there. 7.6, this angle is there. I can make out that this is 80, 60, 140. So this would be 40. What this implies is that this angle would be 40. I hope this is making sense to you. Now I have 80, 40, so of course this would be 60. But if you try to understand, this would be 60. I don't require this angle, but I'm just trying to get across a point that you see these corresponding sides. The angle opposite to these sides are equal. So opposite to 3 root 3, 60, and opposite to 6 root 3, 60. So makes sense. So my answer, angle C, this is my angle. So this would be 40 degree. Hope this is making sense. Okay. So E and F are points on the sides AB and AC respectively of a triangle ABC. Let's make the triangle A. So this is my triangle ABC, and I have marked point E and F. E and F on the... So E is a point on AB. They have said that E is a point on AB and F is a point on AC. So I have marked the points respectively of a triangle such that AE upon AB, AE upon EB, and AF upon FC is equal to half. Basically, what they are trying to say is, of course, we will come to it. What they are trying to say is that, let's look closely at this. If AE upon EB is equal to 1 by 2, this is given to me. Now, let me assume that AE, AE is of length K. Then K is any constant. So EB would be of length 2K. I hope this is making sense. I hope this is not very difficult to understand. See, the ratio is 1 by 2. So I'm assuming that one of the side is of length K, the other would be of 2K. Okay, makes sense. Now if you look at the proportion of AE upon AB, the proportion would be 1 upon 3. Why 1 upon 3? Because AE would be K and AB would be K plus 2K, which is 3K. So this and this cancels. So this is 1 by 3. So the ratio of AE upon AB would be 1 by 3. Hope this makes sense. So basically, this AE upon AB has a ratio 1 by 3. Similar would happen here also. This upon whole of this would be 1 upon 3, which implies that FE upon BC would have a ratio of 1:3, which implies that 3 times FE would be equal to BC. So my correct answer would be part D. Hope this makes sense. Let's move to the next question. Okay, here there is something which I want to explain, and before we start the question, I'll explain. So in a trapezium where line L is parallel to the basis, so let me take a trapezium like this. So this is a theorem, you can accept it without any proof. So in a trapezium where a line is parallel to the basis, so in a trapezium, this is a trapezium, let us say ABCD. This is a line which is parallel to the basis. So this line is parallel to this, and of course this line would be parallel to this also. Okay, so this is the theorem. It divides the non-parallel sides proportionately. So see, DC is parallel to, let me call this EF, is parallel to EF. is parallel to AB. So these three lines are parallel. The theorem is saying that it divides the non-parallel sides proportionately. What this means is that DE upon EA would be equal to CF upon FB. Hope this is making sense. Or I can also write DE upon DA is equal to CF upon CB. So for this question, you can accept this without any proof. Now let's look at the question. So AB is a trapezium, XY is parallel to ABCD. Okay, fine. If this AX is 2/3 of AD. So I can also write this as AX upon AD. AX upon AD is equal to 2/3. Makes sense. So if AX is 2, then AD. Let me mark this. If AX is 2, then AD is equal to 3. Hope this is making sense till here. So they want the proportion of CY by YB. Again, see, all these questions, what you can do is you can easily assume the ratio to be 2K by 3K. Then these questions become very easy. So if this is 2K and whole of this is 3K, I hope you are able to understand. See, what I have done is this AX has become 2K and whole of this AD has become 3K. Therefore, this would be K. So the ratio of dx upon XA is 1/2. I'll write it here. So the ratio of dx upon XA is equal to 1/2. So this upon this is 1/2. So CY upon YB, because as per this theorem, the ratio on this side would be equal to the ratio on this side. So CY upon YB would be equal to 1/2. So D is the correct answer. Interesting question, and I hope you understood what I have done. Okay, next question.